y equals x squared over 2 minus x. Let's have a little look at this one. It's a top-heavy rational function, isn't it? So we need to do some division to have a better look at this. So let's just do the division down here, bit of room. So how many times does 2 minus x go into x squared then? Look at the dominant term here, it's minus x. How many times does that go into x squared? It goes in minus x number of times. Multiply through then. Minus times minus will give us the x squared. And then minus x times 2 is minus 2x. Take them away from one another. And that will disappear. And this, and then nothing, take away minus 2x is plus 2x. So that's what we've got left. Now we ask the same thing again. How many times does this go into what we've got left? Well, it goes in minus 2 number of times, doesn't it? Multiply through. Minus 2 times minus x gives us the 2x. And then, let's just move down a smidge to do this. So, multiply through by the 2, by the x, and it gives us the 2x, is what we wanted. And then minus 2 times 2 is minus 4. So take them away from one another then. This take that disappears, that's why we're doing it. Nothing here, take away minus 4 is 4. So the remainder is 4. So it goes in minus x minus 2 with a remainder of 4. So this is equal to then minus x minus 2 with a remainder of plus 4. So we've still got 4 over 2 minus x. So that's what that equals. So now we can get rid of this stuff down below. Just remove that now and carry on with the problem. So we've done our division then, and we've got this. Now, when we look at this function here, you'll notice that this is a fractional term, and when x gets large, this will get small and will approximate to this value here, won't it? For x large. So this is a straight line, so it's going to be asymptotic, isn't it? So let's draw this straight line here of gradient minus 1, intercept minus 2. So we'll put minus 2 here and draw through a straight line asymptote here with gradient minus 1, like so, as best we can. Okay, that's that done. Now, what else have we got here? So we'll approach this line. Now I'm not going to draw right out all this bump here on the right hand side as x tends to. I'm just going to do it on the graph. The other asymptote is when this is 0, and it happens at 2. So I'm going to mark off 2 because that's when the bottom bit is 0, and this will also be an asymptote. So I'm just going to do this sketch here because there's a lot involved and it would take prohibitively a long time for me to write down all the associated comments. So let's just do it on the graph then. As x gets large, what happens? It approximates this line, but large positive means this is large negative underneath. Positive over negative is negative, so it's just going to be just underneath the line and get closer and closer and closer to it. So it's going to come from there. And then, when we look at large negative for x, this becomes a large positive number, and we get a small positive fraction here, don't we? So it's just above this value. So it's going to be here. It's going to tend to that line from just above. So it's going to come down to here. Now the other area of interest is at 2. So just above 2, if we say 2.1, this will be minus small. 4 over minus small will be minus large. So it shoots off to minus infinity as x tends to 2 from above. So it's here. So it's going to come up here, presumably. Turn, we get a maximum and go down there. That's one part of the curve. But x, so I've already drawn that in really badly with a digital pen. As x tends to 2 from below, here on this side of 2, what happens to this number? Say 1.9 for example. This will be positive small, so the fraction will be positive large and it will shoot up to infinity. So it's going to come down, turn somewhere, go back up towards this line here, and we've already done this side here, it turns here, and we've got a maximum here. So we'll have a minimum. When x is 0 is of interest, easy to get, so when x equals 0, we get y equals 0. Now we don't know where the minimum is. It could be before 0, it could be after 0, which would be difficult to draw, or it could be at 0. And it's only by doing differentiating, which we're not going to do, that we could find it. So now let's just do the derivative. Here y dashed equals That differentiates to -1. This differentiates to 0. Function of a function. So it's plus, and then the minus comes up. -1 this is in our mind's eye. So it's -4 over the 2 minus x squared multiplied by the something differentiated, which equals a plus. -1, so you change that to a plus. Let it equal 0. And that tells us that 4, so I'm just doing this rather quickly, equals 2 minus x squared. Agreed? Y dashed. So this equals 0, so let's move that over there. 2 minus x squared can come up. And then equals 4. So what value of x do we get here? X equals 0. X equals 0. So the actual minimum occurs, when x is 0, we get 4 equals 4. So the minimum occurs at 0. So it didn't do it before. It didn't do it after. It actually did it at 0, which we wouldn't have known unless we'd have got this turning point here. We know it's the minimum. So now we can do the sketch here. It's going to come around here, turn there, and go back up like so to there. And this is the sketch of this function. So we should label it as such. So let's do that sketch then in our widget tool. So it's x squared divided by 2 minus x divided by brackets 2 minus x close bracket from -10 to 10. And we generate the same curve. You see the minimum here occurs at 0. You take a closer look by changing the limits just to ensure that is a minimum here. We've got a maximum, as we said, over here somewhere.